This topic is a Campbell method. Okay, so for basic equation, basic Campbell distribution is widely used for the extreme value. In this case, extreme is mean peak plus maximum rainfall or maximum wind speed, or extreme value, or ค่าสูงสุด or ค่าสูงสุดขีด and Campbell defines a flood as the largest of the 365 daily flow and annual series of the flood flow. The probability of the occurrence of an event equal to the larger than a value x naught is mean, this case is mean the probability of the annual flood greater than x naught is equal to 1 subtract e power negative e power negative y. Okay, and this is connection to this equation is the basic equation for Campbell distribution, and for x is connect to for y is a dimensionless the variable that's related to x and x bar. Okay, and this is so x bar is mean and sigma y x is mean standard deviation of variate x. In particular, in practice, is the value of the x for given p. So p is a probability. Okay, so that is we can estimate, if we know the probability, we can estimate yp, and reverse of p is a return period. Okay, so we can from the return period we can estimate yt. Okay, and this is the same or this equation, and for we know the yt, we know the k, and we can substitute in this equation k multiplied by standard deviation plus the mean, so we got the xt. Okay, and note that from the above equation 7.18 is the same from as the general equation of hydrologic frequency analysis. Okay, and Campbell distribution are applicable to infinite sample size if the n to infinity. Okay. For the practical annual data series of the extreme event, for example, the maximum for the flood, maximum rainfall depth. Okay. And just to remind you that sigma is means standard deviation of variance, and for the sigma square is a variance, is ค่าแปรปรวน. Okay. For the application, a Campbell equation for the practice use. Okay. So in this case, we have to xt is mean the value of the variant x of a random hydrologic series with a return period t. Okay, is equal to x bar plus k. K is a frequency factor times the standard deviation. Okay, and x bar is mean of the variance. So from this mean for k we can estimate k from yt, and yt we can estimate yt from return period. Okay, and for yn and sn we have to look at the table. Okay, at the table 7.3 and 7.4. But for the if n is equal to infinity, we can use the constant yn and constant for sn. Okay, this equation are used under the following step procedure to estimate the flood magnitude to a given return period. Okay, so the first step is we have to assemble the discharge data and note the sample size, find the sample size, and we have to find what is the mean and standard deviation of the data. The second, we have to estimate yn sn from the given the population of sample size, and the next we find yt from given t, and the next you can estimate k and finally we can estimate kxt. This table showed how to estimate the yn based on the sample size. This is to estimate Sn based on the sample size. We can next example will show you how to use this table to estimate the k, the frequency factor